right, here we go. Unbelievable. Here we are. It's been, gosh, many months. Hi, everybody. Welcome to SkyTour LiveStream West. That's not the West right there. That's the East. But West is up and running. I actually need to get a picture of the West to put in here. And I have with me on the line Daryl Mason. Hi, Daryl.
Hello, Mark.
We are live from Arizona. And when I say live from Arizona, I mean live from Arizona. This is our current view. This is one of the things we're looking at right now. And just give you an idea, I'm going to walk around all the things that you're going to see from now on. This is our new screen. Okay, this is the camera control system that you're looking at all around you. And we have all the camera controls over there. We have a dedicated astronomy camera now. It's actually cooled as well, so I actually have to turn on the cooler. Right now the thermoelectric cooler is not on. I'm turning it on right here, and I'm setting the temperature to minus 10 Celsius. It'll take a few minutes for that to cool down, but you'll notice the star images and the noise especially in the images get so much better. It's not even fully dark out there yet, so we're just kind of in a preliminary mode. It's getting there. And so we're going to first I'm going to do is to give you a tour of what we're going to be doing from now on. This is the main screen that we're going to be using. If you remember the other screen, it was a smaller screen. We have more real estate now. The view is now 2 degrees wide, just over 2 degrees wide actually, and just over 1.5 degrees in height. That's the view of the sky. So we have a wider angle view tonight of the sky. So things like nebulae show up beautifully. Keep in mind, tonight, again, this is a testing night. This is not a night that's going to be able to, you can be able to say, hey, can you show me? Because this is a test night. We're not there yet, all right? We're almost there, however. And so we will actually be able to show you some really cool things. I'll give you an idea. Over here on the right side over here, okay, right here, okay, it says exposure 1,000 milliseconds. That means 1 second. So this is a 1 second exposure. So it's not a huge exposure. But if I say, let's make it say 5,000 milliseconds, okay, now this is going to be a 5 second exposure. And a 5 second exposure is going to be one that's going to show us quite a bit more, as you'll see in a sec. So as soon as I tell it to go, you'll see that we're going to do a 5 second exposure. Okay, and I want to change my what's called the bit depth to a little bit higher. And we're actually now, because again the telescope is not aligned yet to the night sky, I don't know what we're looking at. What?
Sorry. No, go ahead.
Why was that funny? I mean, it's obvious. That's, you know.
Oh, well, Murphy's Law, they're gremlins, all
Yeah,
that stuff.
yeah, but that's okay. And just to give you, okay, so this is our camera screen, all right. But I'm going to show you now. We also have a new focusing system, and there it is up here. This focuser up here that we're looking at, this focusing system is gone. This focusing system, it went behind this. I apologize. This focusing system is actually one that's far more accurate. If you notice, these are the number of steps in the focus, 49,922. This is the position where the stars are in focus. And you can see that can go like, 20,000 this way, 20,000 that way. So it's a very, very, did I say very accurate focusing system. And it's also a focuser that changes the focus depending on the temperature inside the building and the temperature of the equipment. So right now, the temperature probe in the equipment tells us that the temperature inside, okay, is 95.6 degrees
Holy cow.
at 9 o'clock at night out in the building. Okay, this is Arizona desert now. Now, these things should be able to handle that temperature without any problem. But you know what? We're treating it carefully. The building doesn't get power. I don't turn on power to the building until it's 6 p.m. at night. That's the only time it goes on, and it goes on and stays on until 6 a.m. Then it stays off all day. There is a narrow window during the day when I want to do maintenance, so I actually have the power come up for a little while after the heat of the day is done, late in the afternoon. And that stays up only for a little while, and then it goes down. And if I miss it, well, I miss it. Then I got to do it later. So this is the focus system right there. It's really accurate, wonderful, has a lot of benefits for us. So, away with
May I
that.
ask a question?
You may.
I'm sorry. Has that told you the high temperature in your building during the day?
If I turn on the power, yes, because it's only on when the
Oh,
power's on.
yeah.
But
Okay.
the high temperature in the building has reached 110.
Oh,
Yeah.
that's not that bad.
No, but I also have a vent in the building that's a solar vent that actually it will start removing hot air at a certain temperature.
Cool.
So it shouldn't, always the operative word, shouldn't affect anything. You know, I want to say hi to Volkish Fraulein. Curtis Horn is here. Cypher 2, what's up, man? Dagger's here. How you guys doing? Renee Cruz, hello. So good to see you guys. I know it's late, but you know something? It's Arizona. It's a little bit different. And Blue Sky, hi there. Papa Tom, what's up? It's nice to see you guys on our return to stream night. There's a lot to see, a lot to do. Tonight is a testing night, and I thought rather than do it in private and secret, I'm just going to be very transparent and show you everything that's going on. Okay, so you got the camera view. Our control system is one you've seen before. It's this guy coming up right here. Okay, this one you've seen before. All right, and all the controls are the same, except you'll see that our focuser right here, where it says connect focuser, our focuser is also connected to that system we have. So this now gives us the access. This is this over here, this middle part over here. In here, this is the telescope computer. You can see the focuser attachment is there, and look at the number 49922, the same as on the other focuser. So it's getting that information from the other system. And we also have a peek inside the dome, because I do have a webcam system that shows us. The roof here is off, as you can see. This is the blackness of space above, and the telescope is sort of aiming up a little bit. Kind of cool. And I am very pleased that the system is now all functional. And I do want to thank Tara Deulis, because she went out there to fix some problems. Of course, Marianne Robb has fixed problems as well. Made this all possible in a lot of ways. You know, she's been managing all the donations for us on the GoFundMe. So hey there, Carmen and Vera Lucia Campos, and welcome from Brazil. That's nice to see you here. And Alex Bronze, good to see you. So we're actually, there's a few other things we can do with our system here, and I'll just show you the screen. Right now we're doing simple 5-second exposures, but with a click of a button, we can do something else. And that is, we can now take an image and we can stack it live right on the screen. So you can see a nearly finished image all in just a few minutes here, because we can live stack. And as we do, okay, you'll for instance, I don't know where we're pointing right now in the sky, but as this goes on, it's going to stack several images and keep on going, 5-second images, and we'll see that it will change over time, right? And then I've got this down here is a very important item. It's called a histogram. Now the telescope is still pointing down a little bit low, and so I'm just doing some testing right now on the live stack right now. All right, but what I'll do is I can, for instance, hit a button to actually do some processing, and if I don't like it, I can bring it back. Okay, and you'll notice that things changed over here. Well, these are values that I can alter. I can change these. So if I want to move these values, I can move them. Now, we are approved for Starlink at this site, and we are going to have Starlink set up, and that means that it'll be instantaneous. We're going to have phenomenal throughput. You'll notice there's some pixelation on the screen right now. That is due to the speed of the internet or the lack of speed out in the desert. But we're getting speeds out there within 3 weeks, actually, according to Musk. We'll have a worldwide Starlink, and we'll have our site up and ready. So within 3 weeks, we can start getting our equipment and put it in. But I just couldn't wait to just go through this right now and see this. Look, we have 17 frames stacked already, 5-second frames. So these are being saved to a special location and automatically uploaded to the cloud, so they'll be available as we move forward. So this is a really cool screen, and let me just kind of move out of the way here so you can see down there. This is our live stacking screen, and if you look down below, this thing right below me here, that little bump right here, this guy, this is a histogram. This is where most of the data is. Most of that data is this blank sky, okay? But some of it are the stars. And so what we do is this line right here, this yellow line you're seeing, that's a slope. That slope right there, that's the line that is the data line for us. That's where all the data is. And so we can actually move and adjust the settings here on our setup and figure out, for instance, where it's supposed to be really black, okay, and move in, a little bit to kill that or move out. And they're all adjustments that we make, and we start with the mid levels here, okay, and we can also do the same thing again, and it'll actually give us an even harsher look at our data. And again, it's sort of a technique to get us in the ballpark for doing adjustments. But none of these adjustments, this is how you saw before, okay? But when I actually did the processing, this is what you saw, right? We're also using a special filter, and this particular filter is allowing us to catch nebula mostly, and we're using a new system, which if you noticed on the telescope view down here, okay, one of the things to notice is that right here you see this right here, that's actually the camera, but this is also the opening of the telescope. This is where the light goes in. So what's the camera doing on the end? The camera's usually at the back end of these telescopes, way out there in the back end. So what's it doing up here? Okay, well, the back end of the telescope, which is what we would call the business end of the telescope, isn't even being used. Normally these telescopes have light that goes down the tube, hits the main mirror, comes up to a secondary mirror, which is where this telescope camera is now, okay? And then it goes down through a hole in the back of the telescope and then to an eyepiece or a camera where you then capture the image. That's what we've been doing traditionally with SkyTour LiveStream. This is different. We've actually added to the front end of the telescope, we've added a special lens in place of this second mirror. So now the light goes down, hits that main mirror, and then comes up, goes through the lens at the end of the telescope and into the camera. It doesn't even go back down through. In fact, what's in the back end of the telescope now, the hole where the camera goes, is a big giant counterweight to counter the weight of this lens up front and the camera. So the telescope is perfectly balanced now. But what's the point of that? Why would we do that? We're doing that because with that, we've improved the capability of the telescope by 25 times. And we've turned it into what amounts to effectively a large observatory telescope. We have a wider field of view, and we have better resolution, and we have a better light acquisition system now. It's 25 times faster. So nebulae that might take 2 minutes to capture with our previous system, we can do in just 5 seconds, or 10 seconds. So we're talking about a lot better capability.
Photographically speaking, you went from an F8 system to an F2 system, correct?
That's correct. Yeah, for
And
those who are familiar with
F2 is,
cameras, f8 is
uh,
reasonably not fast, not slow.
yeah,
F16, F22 is really slow, and that just means the opening in the lens, the camera is really tiny at F22, and it's bigger and bigger, bigger at F4. It's pretty big, but at F2, it's way bigger. Special lenses are required to get to F2 with conventional cameras. Typically, there's not many that go to F2 naturally. Um, uh, by the way, I do have to say hi to Chris, Elliott Astro Imaging. How you doing? Good to see you. And Bobby Burgess, welcome. Bobby, I owe you a book. Don't worry, I have not forgotten. They're on order. And I will do it. I'm going to sign the book and get it off to you. I will need your address. Make sure you get that to Bill, and I will get that and send it to you. And hello, Genghis. What's going on? Curtis Horn, I think I said hi to you before, but you're asking about Bill. Bill is doing fine. He produces our show, SkyTour Radio, on Sunday nights. And it's really, really cool. Hello, Mike C. Welcome. I don't know what this new time is going to cause for problems for folks, but we're 3 hours from Pacific time, and right now we're talking about. I'm right now at 12:30 in the morning here, 12:30 after midnight. So it's kind of tough. Isabella, I want you to know, Isabella from Sofia, Bulgaria is here, and Isabella is one of the people that she's done some beautiful artwork for us. She's also done some amazing photo processing. Isabella, my hat's off to you. Thank you. You did a great job. Keep up the work. If you need any help, let me know. But she's also, you know, reminded me the other day, I think it was yesterday or early this morning, she said, "What's going on with SkyTour LiveStream?" And I thought, yeah, what is going on? I mean, I'm doing all this testing of the telescope, and I'm doing this testing, and I'm working the dome, the building, but nothing else is going on. So it's like, oh man, I figured I'm just gonna start including everybody now. I can't believe I haven't. So I apologize for that, but you're here now, and we're gonna stick out. We're gonna stick out our necks and hope that nothing goes terribly wrong. But like I said, we're testing. We don't have a good alignment with the telescope right now. I did the other day, but then we actually had a solar flare of sufficient magnitude that I think it actually buzzed through the building and upset our settings. So I have, yeah. You remember that, Daryl, the other day?
yeah, it was the first X-class flare since 2017, I think.
Yeah, an X-class flare, folks, and just imagine it. An X-class flare is capable of knocking out power grids. And out in the desert, where you have hundreds of feet of buried cable, like we do to this desert observatory, that's long, what we call potential. And if the flare hits at the far end, or say the energy hits at the far end and at the other end of the cable, there might be a sufficient difference in that energy that a potential gets built up in that cable and fries something at the other end. Now, I do have a very industrial strength surge protector in the dome or in the building just for this purpose. Obviously, it worked. The telescope is still functioning. But the telescope itself was subject to the hit, a direct hit. Even though the power was off, some of the chips got scrambled, and so we lost our alignment. So that's telling me I've got a plan for this, and I have a solution. And I will show you right now what that solution is. Going back to our image here. We're still stacking, by the way. We're up to 106 frames of stacked imagery on the left here. Now, it's a relatively nothing location, so we're not seeing a whole lot. But we're going to do that in the Milky Way as the Milky Way gets closer to us in a little while. It's rotating toward us. So if you look at this telescope, it's sitting on a base, okay? And what I'm going to do is, and I have them here, I have linear actuators. I'm going to actually build basically a table, which is going to be on the bottom here, and over it's going to be a big, giant cover, a shielded big, giant cover. And that cover is going to be, after the roof comes off, that cover is going to be then rotated off. And the telescope will then be available. All right, so two things have to open. The roof has to open first, and the roof can't open, or the roof has to open before this cover will come off the main telescope. The cover is meant to be a shield for the telescope from solar flares, and it's going to be needed desperately out there because it's very dry, and electricity and conductive surfaces on dry conductive surfaces is still a problem. So that said, I'm planning another trip out there to judge how big this cover has to be, and then build the cover, and then shield the cover, and I'll basically make it a Faraday cage, for those of you who know
I
what
was
that is.
just about to say Faraday cage.
Yeah.
Huh.
It could be made of chicken
Fascinating.
wire. It could be made of chicken wire. Okay? But I'm going to make it out of like chicken wire that actually has a cover on it so that I can actually keep dust off it as well. Oh, the other thing that came in is the dust cover, by the way. There's a what we call a dew cap. All right, it's a dew cover, and it's going to extend the barrel of the telescope by another 18 inches or so. And that's very much needed as well. Okay, so let me show you what happens. And again, I'm doing the testing as I now, I'll raise the telescope some, and I'm going to turn off the live stack for now because we're not going to, it won't know how to stack once I start moving the telescope around and moving off the field. So I'm going to get rid of the live stack. All right, the live stack will finish. Okay, and there's the live view, and now what I'll do is go back to our telescope control, and because it's 2,400 miles away from here, I always bring up the video, the live feed, so I know what's going on. And now I'm just going to go up some in the sky. There's the telescope moving. You'll notice the stars are going to do a weird dragged out colorful thing here. All right, so we go up a little more. Yeah, oh, look at that. Okay, and we'll just swing to the east a little bit. The feedback and slowness of the system are going to be replaced once Starlink's in place. It'll be instant. It'll be like watching TV. It'll be smooth, and it'll be wonderful, and that's kind of what we're targeting.
I saw earlier today that Elon Musk has sold all his real estate.
Really?
Yeah, he is renting a little 375 square foot tiny home. He's renting it from SpaceX down on the SpaceX property in Texas,
Yeah.
and that's
Look at
where
that.
he's living right now.
Look at that. We got a satellite going right through the view just then. I saw,
Cool.
the other night, guys, I saw, this is a time exposure. It's a 5-second exposure. I saw no less than 100 satellites go through last night, actually, when I was doing some testing. 100 satellites. I counted them. I couldn't believe it. It's like, wow. You know? So, there's a lot going on. And this was a north-south satellite, too, incidentally. So let's, if I, let me increase this exposure. Let's go up to, say, 15 seconds for fun. Look, another one. See what I mean? They're everywhere. You know, they're everywhere. Yeah.
Wow.
Yeah. All right, so here's a 15-second exposure of this site, this location. And again, it's just, there's no, okay, the solar flare kiboshed my alignment, so I have to literally go from Connecticut out to Arizona to do this again. And I'm okay with that. Okay. So there we go. That's pretty cool. And that's at a, see, there's several, let me explain the factors here. Over here on the right, okay, you notice the exposure setting up here, right here. That says 15 seconds, okay? Well, that's the exposure time of the camera, for sure. But if we look down here, okay, right here, you see gain. This is a gain, and it says auto, and I have it at 420 right now. Now, no, that's not a little secret tongue-in-cheek joke about cannabis, okay? It's just, that's the setting I actually had it at. But this number is a gain which allows you to actually bring in more data, but it also causes more noise. So here it is at one of the higher levels at 544. They can go to 570. And now when we watch the next 15-second shot, you'll see it'll be it'll be brighter, see, and it's got more noise in it. The purple background is due to some of the noise. But we can take that down and adjust this dynamically. We can stack this dynamically. It's really a hugely improved system now. And by the way, we're using one of the #1 cameras on the market for astrophotography. And I want to thank, and I'm gonna be putting their names into the streams. Starizona in Tucson, Arizona. Starizona has made this happen because they have been outstanding partners in getting this thing up and running with me. Okay, I'm using their system called the Hyperstar, which is that lens system on the end of the telescope I told you about. Okay, the Hyperstar is doing a phenomenally good job, as you can see. And like I said, once aligned, we'll be able to go places. Actually, if we find something that we recognize tonight, okay, then what I can do is I can actually set the coordinates and sync it right there, and basically align the telescope for tonight. And again, solar flare did this to us. Okay, so I'm going to do now is I'm still a little bit west of what we call the meridian. I'm going to go east of the meridian and see if I can eventually hunt down Antares. And that's going to be, and I know where Antares is, and if I can find Antares, then I will be able to, I'll certainly be able to sync the telescope and set the coordinates. So we're going to go east, and that means to the right in the image of the right there.
The smaller scope atop your main scope, is that a guide scope?
Yes, it is. It's an automated tracking system.
If they were pointing at the same place, and you had a camera on that, that would be like your digital finder scope that might give you a wider field of view and
Yes.
let you find Antares or whatever you wanted.
Yep.
In such circumstance.
I agree. And it's not a bad idea. Okay, so let's see where we are now. The only problem with that, Daryl, is that scope is a closed system. I can't put anything on it.
Okay.
But I wanted to get a small camera for the finder itself.
Yeah.
And mount that so I can have a wider view, which is kind of cool because then you can just consult the finder and say, oh, well, there's Antares. It's a big wide view. So, I'm sure that in time we'll be able to get it. I'm actually going to do the following. Over here on the right, you'll see we're at 15 seconds right there. And our gain, and I didn't really sufficiently explain what the gain is, but the gain is like turning up, say, the gamma, or increasing, not the brightness really, but it basically increases the faint data and brings it more toward the front, so you can actually see more of the faint data. Okay, so if I drop the gain down now, I'll say to let's say down low to like 100. Okay, and let's go and say we're going to make this a 4-second photo. Okay, we're not going to see all these stars. Okay, all right. So there's 4. It's going to take it. It's black. It's truly black until it takes the first photo. So we see a couple of the stars in 4 seconds, but we only have a gain of 91 right now. If I turn the gain up to about 300 and some odd, okay, and let's bring it down. Okay, now you'll see that a lot more stars come out. Okay, and if we go way up, then you'll see even more. But see, what we're going to do is introduce noise. This camera is amazing for the low noise that it has. Currently, our temperature is minus 7.8 Celsius in the camera right now. That's pretty good considering that and how do I know that? Well, because the camera has a cooler on it, which you see right here, cooler. Okay, it's on, and over there on the right of that, you can actually see that my target temperature I set it at is minus 10. All right, and down below that, grayed out here, right here, you can actually see minus 7.8 is what the temperature is now. And that's important because by cooling the camera, the amount of noise you get in your image, like all around you here on the screen, is far less. That camera's frigid right now, and it's 95 inside that building, 95 degrees Fahrenheit. Okay, so that's what, 36 or so Celsius. So the camera's sitting at minus 7 right now, and that's probably about all it can pull, considering that the temperature is so hot in the building. So it's really kind of cool. I'm telling you right now, these stars you're seeing here, you just won't see this many stars from SkyTour LiveStream East. I hate to talk down to SkyTour LiveStream, but that's kind of what happens. Okay. I want to say hi to Leslie. How are you, Leslie? Leslie Trailer. Nice to see you. Thank you for coming and joining us tonight. But I'm gonna go zipping around here in the sky. I'm gonna leave the exposure. I'm gonna leave the gain up high, but I'm gonna drop us down to about 500 milliseconds. So I'm gonna say 0.5 seconds. So half a second exposure. And you're gonna say, "What are you doing that for?" Well, you'll see. Okay, so that's what we're gonna see, right? So it doesn't look like much, but what it's going to allow me to do is move the telescope around and see, kind of an almost real-time response as I do. And I'm going to move this a little bit lower out of the way. I just want to keep an eye on the scope and watch what it's doing. That's all. So if we move a little bit more eastward here, you'll see the stars move. Okay. All right, there we go. All right, and then a little more. See, you don't even see the telescope move over in the image over there. Okay, but it does. I'll do it longer this time, so now you'll see it visually move. There, you saw it move. Okay, and now we get some more stars here. We're actually heading more toward the Milky Way right now, so it's kind of cool to go in that direction right now. As the summer wears on, ooh, that was cool. Let me go back. I think we had a couple of bright stars there. There they are. That's kind of neat. Let's just pop those over a little bit more. Okay. As you can see, one of them is kind of a reddish, and one of them is blue. Okay, and I've also got the telescope set to move a lot when I tell it to go. So what I'm going to do is go into my telescope computer here, and I'm having fun, by the way. This is great. I'm glad that you guys are along for the ride. And I'm going to tell the telescope to actually go a little bit slower.
Mark,
Yeah.
Curtis Horn is asking which camera you have.
I have the ZWO ASI 294 MC Pro, Curtis. And that's the 294 MC Pro. It's sort of like probably the best camera for doing this kind of outreach. It has a lot of flexibility and features.
It's a one-shot color camera, correct?
Yes. Yeah, which is kind of fun. Let's see. Let's take us a little west. Yeah, a little more west. Oops, wrong way. Sorry. Okay, here we go. All right.
Those are the same two bright stars we saw earlier, correct?
That is correct. And what I'm going to do is I'll stop here and I'm going to let the guide system lock on, which takes 15 seconds. And then I'm going to take some longer exposures and see what else is in the field. We're at a high gain right now, and that's probably a little too high. I'm going to drop that to 450 or 400. And it'll immediately get a little bit dimmer, but we're going to increase from literally half a second. Look at half a second. We're seeing faint stars here, guys. So this is pretty good technology. And now what I'll do is I'll increase this to, say, 10 seconds, 10,000 milliseconds. Okay. All right. And that's in that field over here that you can see by my cursor. And now when I hit the key, it starts counting. And down here you can see the green progress bar that shows you that it's moving. It's going to go 10 seconds and then we'll see it. And keep a watch because there will be... Hey there, Tim F. You will see some satellites as well. Wow. This is pretty. I'm telling you, it's just a beautiful star field, you know. And you don't need my face on here so big, so I'll move out of the way a little. Okay. I want to go to... I'm going to do a test. I'm going to do a 25-second photo of this region. See what we get. Again, this is just a one-shot photo. I can stack 25-second photos on top of each other if I do that live stack thing again. But that'll come if we find a really cool object to look at. 20 seconds got me the dust clouds around Antares, which I put on Facebook that you might have seen, guys. Okay, here we go. First one. Okay. Yeah, and look at, now you notice that the color of these stars comes in, right? And what we can do is we can actually zoom on this field here. I think we can go, say, 75% maybe. Right, and then move up a little bit.
What's zooming? Is that a digital zoom?
Yeah, it's a digital zoom of the actual photo we just took.
Uh-huh.
Yeah. Okay, so now you can see the colors of these stars. This one's distinctly orange. That one's distinctly blue. Really pretty. And let's go back to auto. All right. That's cool. And now what I'm going to do is drop us back down to 1 second and start hunting for something we might know. Because I do have a way of setting us in a synchronized mode with the sky if I can find something we know. Okay. I shall bring up the telescope now in our control system. By the way, this control system here, you're missing a lot of it because this is actually a full screen thing and I'm just using the little control segment. There's a whole nother set of screens that goes with this that will allow me to look at things and show you different things. But right now I'm using something called SharpCap to do all the capturing. Hey, Dave Schmidt. Good to see you. And it's a lot of fun we're having tonight, just poking around the night sky. Solar flare destroyed our alignment of the telescope. We'll fix that. And so that's that. And James Dugan, how are you from Australia? Nice to see you here as well. So let's go poking around, shall we? Let's go a little more east. You'll see the stars streak away. Or not. Oh, duh. Sorry. It said 1,000 seconds. It was supposed to be 1,000 milliseconds. So now you'll see what however many seconds that was before, but it'll probably have some streaks in it because we moved the telescope. Yeah, look at that. That was cool. Okay, now we're at 1,000 milliseconds, what I wanted to do, and now we're showing folks before we have a new focus system, which is tied to this. All right, here it is, and it also gives us temperature because it's a temperature-dependent focus. As the temperature changes, now it's only 94.2 in the dome. That's Fahrenheit, and that would be 30. Let me get a Celsius. 34.6 Celsius. Okay, so 94.2 Fahrenheit in the dome right now. I'm sorry, in the building right now. And if I enable this, it'll activate temperature compensation. So as the temperature changes, the focus will change. All right, on the system. And what you would do is you would actually take the time to refocus, but the system can do it automatically. I was doing some focus seeking work the other night, and it was actually pretty interesting watching how it was seeking focus. It was changing the focus to try and get the stars to their pinpointiest, which I've accomplished here. All right, let's as we keep going, it's going to get a little bit more starry. Ooh, look at that star. That is a pretty cool little orange star right there, right in the middle. See that? That looks like a little orange dwarf.
Uh-huh.
I would like to, a little red dwarf. Well, let's do 10 seconds on that. Not 100,000, but 10,000 milliseconds. Yeah, we should see. I want to see the color of that dwarf a little better, because we're only doing 1 second. Oh, look at that! And we can stack these too. Remember, like I said, I think maybe. And keep in mind that the slowness of the whole system is due to the fact that we do not have our Starlink up. It is actually approved for the site, and I'm just waiting for them to say it's a go. Do it, and we will then get our Starlink equipment. And that's going to be something that happens, I think, within 3 weeks, actually, because they said over a week ago, 4 weeks to worldwide Starlink. I've been checking the satellites too, and we've got lots and lots and lots of satellites over us down there.
Mark, this is a shot in the dark, but the group of stars down in the lower right corner.
Down here?
Yes.
Okay.
That looks suspiciously sort of like the butterfly cluster.
Okay.
But I don't know if you could bring that toward center and get a better look at it. Which that would be down near the tail of Scorpius.
Yeah.
If that's what it is.
Well, I'm wondering if those stars were basically Shaula and Lesath,
Yes.
But I think that Lesath would be the less bright one, and that one was not. We're talking about the little stinger on the scorpion's tail. I don't think Lesath is red. I think it's a blue star. So we wouldn't see that. It's actually a B2, and Shaula is it's a B2 as well. Subdwarf, subgiant, no subdwarf. Okay, let's try it though. We'll go for it. Let's go check it out. And first thing we're gonna do is we gotta come back this. Drop our.
This was just a shot in the dark for me.
It's all right.
I'm not used to your image scale yet, and
yeah, it's 2 degrees across, and
yes,
1.5 top to bottom.
Yeah.
Okay. Let's find out if you're right. This is fun. Okay, not 1,000 seconds. It did it again. I gotta explicitly tell it no. Okay. Okay. All right. So we're on a 1 second delay. Okay, there we go. Okay, so here is the telescope. Here is our connected system, and I'm going to zoom us over to the right a little more and then head down a little bit because Daryl wanted to check out to see if that was the butterfly cluster. So now let's go south and see. One more. What do you think, Daryl? I'll have to bring it in, take a longer exposure here just to see.
Yeah.
We'll do a 20,000, or no, a 20-second exposure. No.
It may have just been.
Hang on. I'm in the middle of taking the exposure. I apologize.
No worries.
Okay, so here we go. Okay, it's underway. Isabella, the time in Arizona is actually 9:51 in the evening. Okay, let's see what Daryl gets here.
Clock's about 6 minutes slow. Oh golly. I do see sort of a butterfly shape, or at least one side on the right side.
This looks like, the butterfly wings, doesn't it?
Yeah.
Well, you know what? Let's find out. Now, if that's down by the tail of the scorpion, then that's going to put us somewhere around minus 40 degrees declination and somewhere around 17 hours, right ascension. So that's interesting. So what I'm going to do, actually no, the butterfly cluster would put us more at minus 33.
What is butterfly cluster? M7? M6?
Butterfly cluster is... let me find out here. I'm trying to capture it. I don't. I'm trying to find the entry for it. I mean, I have it, but it just doesn't seem to have bright enough stars. Actually, I think it'd be more striking than this, to be honest.
I think you're right.
Okay, well,
it would. Yeah, Messier 6 is the butterfly cluster.
Okay, thanks for doing that. I was trying to do a few things at once.
But I think you're right. It would be brighter. And probably more stars in it, too. It's just a
little more compact, but...
pareidolia, wild-ass guess, something like that.
That's fair. That's okay. Okay, let's bring up the telescope again. Again, like I said, to those who heard this already, we had an X-class flare from the sun. And what happened was the telescope has a surge protector, so all the electronics are protected for, that explosive attack of high energy protons and electrons from the sun. But the telescope itself, inside the building has a metal skin, but it's possible that it's not acting enough like what we call a Faraday cage to protect the contents from the solar flare. And I noticed the telescope was haywire right after the solar flare, and not before. So I think maybe that's the reason why we ended up with this problem. But it's not a problem after all, because look at this is part of the growing pains, right? So we'll figure it out. We will figure this out. All right, let's head to the east some more. All right, and we're on 1 second. We're on 1 second here, and I'm just kicking it over a little bit at a time. And we're actually heading a little. We're not really going too much to the east. Actually, we have a little ways to go, I think, and I think we'll be able to hit the Milky Way. You'll notice it because there'll be a lot more stars all of a sudden, and that's going to be kind of cool.
Can I suggest something?
Yeah.
Do you still have the time for the observatory? I see your timestamp up at the top right, and that's for your location, correct?
No, this is the observatory at the top left here.
No, it's top right.
Oh, yeah, top right is here. For me, yes. And, that's actually kind of in the way, isn't it? I'll have to deal with that.
I saw the observatory time earlier.
It's over here. It's 21:56:27.
Stand by just a second. Okay, I still don't see it. Where are you pointing at?
Up. Okay. Right there. You see that?
Okay.
Right
yes,
here.
I see that. 21:56:54.
That's it. That's right.
Yeah. Could your time be off there, which is what's throwing your location?
No.
That time is off by. I just double checked U.S. time. It's 11:02:30:40 at my time.
Okay.
So you're about 4 minutes slow.
Okay.
4 or 5 minutes slow. You see what I'm saying?
I do.
If computer time is off, that could be affecting your pointing. Just a thought.
No, I understand. But it's off by like 50 degrees.
Oh, well, okay, never mind.
Yeah. No, it's not like just a minuscule amount, Oh, there's another beautiful little red star. Look at that.
Huh.
What's interesting? Okay. What's interesting, folks, is that this kind of astronomy is precisely what people did in the early days of astronomy. They just scanned the sky. I mean, the other day, I sat here, and all of a sudden a satellite comes in, and it's just going right across the screen, nice and slow, in real time. It was really quite cool. It was really quite cool. Yeah. So, we have a ways to go still, I think. I'm going to really push it over a little. There we go. I'm moving us slowly over, just trying to get us closer to the more dense stars of the Milky Way here. A little more. Like I said, I could have done this on my own, but I thought you might like to see everything that goes on behind the scenes here. At the end of the night, you'll actually see me close the roof too. You'll see the roof close as well. Okay, let's do a exposure here of, say, 20 seconds.
Isabella has a question for you, Mark, when you have a second.
Okay. Uh, yeah, actually, Isabel, yes, you're going to have all the raw images up there as well. It'll be a little bit different because I did set up the cloud a little differently. Every photo that's taken, like we're taking tonight, these are all getting uploaded to the cloud. And they're going, oh, look at that. Right in the middle, we got a little satellite.
Yep.
And it took 20 seconds for that trail to get made, by the way. So
You have something nebulous down
look
in the
at
right-hand
that.
corner.
Yeah.
Right there.
Yeah, we should identify that, and then we can. The other thing I'm doing, by the way, folks, is something called plate solving. I just have to install the software on that computer out there, because unfortunately that software is right here in my memory stick. But I'm going to be installing the plate solve software out there as well. And when we do that, we're going to be able to literally be in a field like this, and the telescope will say, I know exactly where that is, and then I'll align for you. It identifies the star fields. I mean, talk about a complicated program. That's a globular cluster down there, Daryl.
Is it?
I think so. So let's go back here. Let's drop this down to say 2 seconds. And that globular cluster might vanish, but we'll be able to get to it. Yeah, but we can bring this star up and bring this over. We know it's right here. So let's do that. Oops, wrong one. Sorry. Okay, here we go. So we're going to go drop it south a little bit. And it's taken 2 seconds now. Okay, drop it one more. And then we're going to move it to the left. Okay. Now we're going to go east a little bit. And it'll bring that over. A little more. A little more. Okay. Maybe one more. Okay. And now we'll let the telescope capture that. What I'm going to do is I'm going to move it up a tiny bit. Okay, good. Now we have to wait 10 to 12 seconds. And while we're doing that, 10 to 12 seconds for the auto guider to catch on. And then we'll do a 20,000 millisecond exposure here. This is more like the astronomy that I'm used to doing. Okay. All right, here comes a 20-second exposure. The guider should have had time to get in. All right. Okay, the green bar is almost filled for this exposure. You'll see it in the middle of the screen. I think it's going to be right about here. Oh, it's over there. Look at that. And look at that. That satellite is still moving. Check it out. Yeah, see, we're getting more into the Milky Way now, guys, because you can see that we're seeing some modeling that might actually be worth stacking here. Because we might actually see a new exposure came in just now. Can you see that? It moved.
Wow.
Yeah. Yeah, so that's kind of cool. Let's try a live stack on this. Just for fun. Okay, this, let's pause. I'm going to clear this and let it start over. All right, and wow, look at that. Do you see what I see, guys?
Dark nebula.
You got it.
Might be a Barnard object.
Welcome to the southern skies. Check it out. Yeah. That's a beautiful dark nebula in there, I think. And of course we're getting the trail of the satellite as well. Wow. This is just stunning. This is beautiful. And it's stacking right before your eyes too, which is really kind of cool. Oh yeah, James Dugan, you're talking about the giant comet. Daryl, I think you heard about this story too. You might have mentioned it to me, in fact, as well. Yes, and there's a large comet that has been discovered entering our solar system, but not to worry, it's going to take quite a long time to get here. I actually don't remember the time that it takes to get here. Daryl, do you remember that?
About 10 years.
Is that what they said?
Yeah, 2031 is when it's at perihelion.
Yeah.
And it's going to be out by the orbit of Saturn at that time.
Yeah.
So
that's about as close as it's going to get, though, I think.
Yes. They think it may be up to 300 kilometers across.
Okay.
And boy, if it was coming closer, it might put on a heck of a show.
I bet.
But they're thinking with it as far out as Saturn's orbit, it may still not be much to see, naked eye or in an amateur telescope.
Yeah.
I guess we'll just have to wait.
Yeah.
And the object was actually, I forget its designation, but the object, I believe, was actually discovered in 2014.
Really?
Yeah.
Okay. So, I just want to point out, we've stacked 7 frames so far, and you'll notice that this dark nebula, we've stacked 7 frames, so I'm actually going to try a little image processing, an instant process right here. See what we get. Oh, look at that. Look at that. There's a globular cluster here. There's a faint satellite traveling here. We got this beautiful dark nebula. We're now heading toward the Sagittarius star cloud is what I'm thinking.
Can you do a digital zoom on that nebulous object?
Yeah, I think it's a globular, but I can. I certainly can. Let me go, say, to 75%. And then make my way over there. This will be instantaneous, folks, when we get Starlink up and running. Yeah, there it is, Daryl.
That does look like a globular, doesn't it?
Yep, sure does. It sure do. Yep, that's pretty cool. And let's go back out and check what we look like now. We got 11 frames stacked. Ooh, look at that. That's pretty cool. We're actually, this is really quite amazing. We're seeing some really nice dark clouds that are starting to show up here. Let me try another processing option here. Yeah, see? Look at that. Look how absolutely clear those are when you do this processing here.
Wow.
Isn't that wild?
You've got a big loop of one up to the upper left of that cluster.
Yeah, actually that, I think...
Top left corner.
Yeah, I see that up there. I think I'm also getting some darkening because of what's called a flat field that's required. So I'm going to have to... What happens is, like, when you take a picture, what happens, guys, is that the photos will actually be modeled in some way. You'll see darker, like up in the corners, it's usually dark. In the corners, it'll be darker, and in the center will be brighter. Okay, and that's normal. And It's the way the light is getting into the corners of the sensor versus the center of the sensor. And in this particular case, when we do this, we're trying to figure out a way to make that all flat. So to make it flat, one way to do it is to take an illuminated panel and put it over the end of the telescope and take photos of different exposures to try and look at the modeling and use that as a model to remove the modeling from the other shots. Well, instead, what I've done is in Photoshop, I wrote what's called a Photoshop action that actually creates a synthetic flat field. It studies the image and removes that what they call vignetting around the edges and makes sure that we get the proper view. And then you can actually go process. Let me go back and do this. This is not destructive, by the way. When I do this, it doesn't ruin the picture. But look at this. Again, we're seeing some really look at that detail right there. That's pretty exciting, isn't it?
Yes, that's all real too.
Real time.
You can see a lot of modeling across the screen there.
Yeah. Yeah.
That toward the upper left and that toward the far right.
Yeah.
That's really something.
Isn't that beautiful? And
are we seeing that cluster through a dark cloud?
Looks like it's reddened. And that would be explained by this dark dust in front of it, because that does redden light, just like clouds and thick air between you and the sunset makes the sun look redder.
Yeah.
Boy, isn't this something? This is really something. This is only 21. This is 21 frames stacked. Let me. Okay, I'm gonna save this image. Okay, there it is. It's been saved. And by the way, we're saving it in a different format. We're saving it in a format called FITS format, FITS. And that's an astronomical file format that's used. It's actually kind of a legacy format. Most people use other types of RAW and TIFF. But it's really cool. Oh, is that the comment?
Yes.
Look at this, guys. This is beautiful. And you can even see, if you look at this cloud over here, you can see like that there's some, you can almost see a three-dimensional view to this cloud. I feel like I'm probably a little too far over. I need to go over a little bit more, don't you think?
Sure.
Yeah. Okay, well, I'm gonna terminate this live stack right now. I saved it. So that'll be up on the cloud. But isn't that beautiful? My gosh, that's just something. And I think I'm trying to think if there's another way. I think I can do this.
That's really something.
Yeah. Beautiful clouds. But this is what Arizona has for us. I mean, I don't even have the telescope aligned. We lost the alignment because of the solar flare. But we can still find our way and do some really good things. Very dense clouds of stars in here, that almost merge into a blob. And this is not central brightening of an image, because it's not central right here. It's actually not, it comes down from the top and it starts here and keeps on going. So that's actually pretty cool. Wow. Okay, we're going to save this stack again as a 16-bit stack. I could have saved it as a raw 32-bit stack, but the data wasn't captured that way. It's only over here as what's called raw 16 for those that were paying attention. All right, now what we'll do is we're going to go down and we're going to pause the stack right now. So we're not doing live stacking right now. All right, so now I can go down to the 1 second at 400. So we'll say 1 second. Gosh, look at that. That's really pretty. And now what we'll do is we'll go and I'm going to go back to the live feed here. Okay, the images are not gone. Okay, they're still here. All right, and I'm going to move us over a little bit.
Joys of wide field astronomy.
What's that?
The joys of wide field
Oh,
astronomy.
yeah, I know. Let me just get rid of this. Okay. All right, so I'm at a second, and let's bring up our image again. I'm sorry, the telescope. Okay, and let's actually go over a little bit more. Okay, that was interesting. So now let's try one more little jog. Okay, so now what we'll do is we'll come back here. That's gonna, while that's doing that, we're gonna do a another 20-second, do a 20-second photo and see how it looks. And our globular cluster is probably going to be out of the view, maybe. I think it will be, but we'll actually be able to see more of that dark nebula once we do the live stack again. Okay, here comes the first images coming up. Ooh. Let me undo. I see lots of dark nebula here. Okay. Let me bring up the live stack again. Live stacking is paused. We're going to clear it and we're going to resume. All right. And it's underway.
Your scope is
Oh,
basically working at 508 millimeters focal length right now.
That's right. It's like
See, what would it take to figure out what kind of magnification you're getting? Like the native magnification of the system?
Oh, yeah. Well, knowing the field size, and then you plate solve. You know, well, I mean, look at this, Daryl. Right, I just couldn't stop. Look at this, right across this, right here. There's a
I'm
massive
looking.
dark lane in our galaxy right here.
Yep, you got a big dark spot up the top right.
I do. And let me see if if processing this makes any sense right now. Oh, wow. Wow. Oh my gosh, you know.
Well, I was just thinking this is almost like a binocular view.
Yeah, it almost is.
If your field is 2 degrees by 1.5.
Yeah. Yeah. Jeez, look at these dark clouds, folks. This is okay. Dark nebulae, okay, are dark dust, and that dust comes from the soot, SOOT, the soot generated by red supergiant stars and their outer atmospheres. It's not. it's generally, in general, it's diatomic carbon. Okay, 2 carbon atoms that are bonded together that makes it. But there's other kinds of soot as well that go with it. Carbon compounds, basically. What happens is it's so very cool in the outside environment of the outer edge of that star relative to the inner parts of the star that it's actually cool enough for soot to develop, you know? And that's what we're seeing here. I actually want to go up more because I want to capture what we're seeing
Yes.
here.
Uh,
I do. This is 7 frames
yeah.
stacked so far.
If you wanted to sort of compose an image, if you can just see that cluster over on the far left-hand edge,
Yeah, I
maybe
see
if
it.
you were to bump that just a hair to the right and then go up, try to catch that darkest cloud up at the top right.
Yeah, I got to go east a little bit more and then go up literally about half a degree.
Okay.
Yeah, so we're going to bring this down to here.
All right.
Okay, this is part of it, but that is, I think, a major contender, something that we really got to check out. All right, so let's get rid of the live stacking for now. And then, wow, look at that. Oh, this is crazy. It's just amazing. I mean, I'm so pleased with the performance. What can I tell you? All right. What do I want to do now? I'm going to 8 stack. What's this one here? Okay, live stack. Actually, I'm going to get rid of the live stack right now, and I'm going to head east and then north to bring this down. I think that's going to be kind of cool. So let's do that. Let's drop this exposure down to our 1,000 or 1 second, I should say. All right, it's 1 second now, and now we're gonna go down here. So again, I apologize for the sun whacking our telescope.
Mark, I will be right back.
Okay. There we go. All right, and maybe a little more down. Yes, I think this is where we want to be. Wow. I don't know, folks. I'm telling you, this is something. Okay, we're going to do 24,000 milliseconds, 24 seconds. And we're going to be stacking those. But first, we're going to do this, get a photo. All right, it's starting up now. Down below, you see the green progress bar showing you the exposure we're currently in. Okay. And we will be live stacking that as well. I just want to look at what it looks like, make sure it's relatively close. I'm pretty sure that's it right there. So I may have to come down a little more. But I'll live stack it anyway just to see what we get. Okay. That's the previous one. We're going to clear that one. And now it's going to automatically start doing this next one. I hope you guys are having a good time. I'm astonished at the views tonight. I'm impressed. If I can identify anything, I'm going to turn right around and wow. Oh. It's such a big dark nebula that I haven't even come close to capturing it all. Isn't that amazing? And look at that little satellite right there. Wow. This is just so many stars. Reminds me of, was it 2001 Space Odyssey? My God, it's full of stars. You know, it's really something. Ah, look at all this detail. 2 frames stacked so far. Just unnervingly beautiful. I gotta let a few more stack before we do this. Look at that, Daryl.
That's really something.
Yeah, I didn't bring it down even enough. I mean, we saw the little edge of it, but, you know, I should have come down even more. It's okay. We have this long Milky Way trail here. This is beautiful. Okay, I'm going to, we've got 3 frames stacked. Let's try to see if the the auto stack will work a little bit here.
That one at the top right has to be a B object.
I would think so.
Don't know which one, but
Yeah. Let me stack. Let me do this. Oh,
wow.
wow,
Wow.
wow. Oh man, look at that. Ah, that is just beautiful. Look at our Milky Way, guys. This we're looking toward the center of our galaxy. I could probably get an approximate location out of this if I can just pin that down. I think we're actually well east of Antares right now. I think Antares is, it's actually past the meridian right now, so it's actually heading over to the west, and we're looking to the east at the galactic, near the galactic center, kind of near the Sagittarius star cloud, I think. Jeez, and let's find out. Boy, this is, see, it's hard to tell. When I get the plate solving installed out there, it'll be able to tell us, oh, we're exactly here. It knows exactly where we are. It adds a whole level of professional solution to the observatory, and we're gonna be able to do that. Keep in mind, okay, you ready for this, guys? This is a 24-second exposure. For those of you familiar with cameras, you don't take pictures like this in 24 seconds. You take pictures like this in like 10 minutes. 10 minutes. And look at the detail in this cloud we're getting. This is astonishing detail. This is really beautiful. Daryl, I feel like I want to go north more, you know, and just...
You're reading my mind.
Yeah.
Maybe nudge it just a little farther to the right again.
Yeah.
The little dark cloud in the lower left corner, if you could scooch it over toward the left just a little more.
Yeah.
And then go up more, which I guess is north.
Yep.
Try to get the little one in the lower left and the big one in the upper right.
I mean, this one here?
Yes.
Well, if it's going to go in the lower right or lower left, this is not going to come down anymore. And that's what I'd like to do, is bring it down.
Well, yeah, do what you got to do.
Okay. Let me, let's do that. Let me go over here. Oh, you know what? I'm really happy I'm doing this with all of you, because this is proof that it happened. And we're streaming, so this is all going to be on the stream, seeing it live like this. I'm still working out the details of this particular program to see if I can get this larger on the screen, you know, and fill the screen more. But I'm just beside myself with these views, and it's one of those nights which is just spectacular. It really is. And we actually had some clouds out there today. It's the monsoon season there, so they do have clouds and stuff during the day sometimes, and rain as well.
Monsoon season here too.
Yeah. Okay.
Now, actually, we're in a flash flood watch right now.
Yeah, we're in a heavy-duty thunderstorm warning here, and we lost power. I was concerned I might not be able to, might not be able to do this. Okay. Right, stack is paused. And let's get rid of the live stack, and it's going to go back to this dark, starry sky. Look at how many stars, and look at this snaking dark nebula here. Wow. All stuff.
That's really something.
All stuff that we could never have seen. That's stuff invisible from here, as a matter of fact, unfortunately. But that's the way it is. Okay, that's what it looks like. So we're going to bring these stars down and over. These guys right here. All right. So that means we're going to go north, and I'm going to do it in little tiny drips so we don't lose track. Okay. There we go. One more. Okay, and now we're going to take this over here. And to do that, we got to go east a little bit. So move all this over. Okay. A little more. A little more. A little more. All right. And then one more jog north. All right, should we try that?
Sure.
Okay. Let's go Milky Way dark nebula hunting. 24,000 or 24 seconds. And let's go. All right. And here we go. We're underway. Exposure is being taken. You can see it over there. Right down here. The green bar. I'm really impressed with this system. What can I tell you? Oh, Leslie, you're welcome. This is amazing for me too. It really is. Ah, there it is, dead center. Oh, okay. This is gonna be the winning shot tonight. And hello, and look at Bonnie's Anahata 77. Hello. Yes, it's beautiful, Bonnie. This is a dark nebula we're actually building right now. I'm gonna live stack this so you can actually see it. See, this is like that's the old one. Sorry. This is this image we just saw, not this one, but the darker blue one. That's what the raw images look like from SkyTour East when we take these images. But from SkyTour West, it's actually very different. And we're going to see this new one here in a second. I should have hit clear. I apologize. All right, so I'm clearing it out. So now it's all cleared out, and we're doing a whole new stack. Now it's being auto stacked on it for us right now. I can't wait to see this. And we're going to stack 3 images before we try to do any auto processing on it. All right. Oh my gosh, look at this. Look what it
just gets bigger and bigger.
It does. Look at this over here. It's like I'm just oh, wow. As Christopher Walken would say, wow, this is cool. Wow. I'm impressed with this. Look at that. Holy cow. I don't know, Impressive. Yeah. A little processing on it. We're getting details I have never seen before.
You would have gone right by this at F10.
Oh yeah, wouldn't even known it was there. Bonnie said hi to you. Anahata 77.
Hello. Hello, Bonnie, Anahata. I always just thought of her as Anahata.
Yeah. Look at this down here. We got this down here. Beautiful. Look at this. Beautiful. We've stacked 4 frames so far. I'm going to drop the gain to 350 and see what a difference that might make. It'll drop the noise overall. Look at this, though, huh?
Something tells me after this you're going to go up and to the right again.
You think so?
Yeah. 'Cause it just keeps getting deeper and deeper.
It does. It does. Look at this image. Look at that.
Darker and darker.
Here's the thing about this, that soot I was telling you that the supergiants make, it doesn't get out into the universe until the star goes supernova. So you're looking at the result of many, many, many millions of star deaths, okay? This is the result of that process. I'm just messing with the stuff here, so don't worry, I'll get it back.
So where are you putting the raw files you mentioned earlier? I think it was Isabella asked you about.
Yeah, and the raw files are going into a directory that's without processing. Okay, that's the raw shot without processing. The raw files are going into a directory which gets shipped up to the cloud and is automatically available on the cloud. What I want to do is give everybody access to the cloud directories so they can just go look at the results automatically. Just go and go look at them. And that's what I'd like to do.
And somebody is reprocessing some of these files?
Isabella is. Actually, she's doing it.
Yes.
And I am, of course. Yeah.
Wow.
Yeah, I'm going to... I can also do some dynamic processing here. Let's try some dynamic processing. We can do this. Come back the other way. Oh, look at this. Oh, we got a satellite in the middle of that cloud. Let me just bring it back. Wow. This reminds me of my professional observatory days, because you'd be sitting there looking at the screens, and just waiting for something to come in. Then when it comes in, you go, wow, look at that, Really just astonishing.
You said you had a satellite.
It's right.
Is that tiny thin line just below center?
Yes.
Okay.
I'm dropping my white level back a little bit. So see, I can do processing on the fly here, which is kind of cool.
Yeah.
And there's the white line I was talking about.
Yeah.
What's neat is this process, I can actually eliminate that white line automatically, magically in here. It's just something else. Yeah. Yes, James, you're actually seeing the 3D nature of the galaxy this way. But let's go this way now, as Daryl suggests, and I agree. Let's head up there. So first things first, we stacked 14 of these, which I'm saving. I'm saving these as raw, okay? I'm not saving them as you see them here. You'll have to, if you're going to process these, you have to bring that data out yourself, okay? So that's saved. And now I will pause this stack. Okay, and then we're going to go to a 1 second exposure again. All right. And that's going to give us our ability to do our finder. So we want to bring what's up here down here. So we're going to actually move quite a lot here. So let's bring up our two controls, our telescope control and our imagery. And I'm going to go up to the north. There we go. We're going to put this thing just below center. Move out of the way here. You don't need my face gawking at you. Okay, and then we're going to move all of it to the east, which goes to the left in the image. So this is going to come over here more.
Yeah. There was quite a line of stars there.
Yeah.
A little crook in it.
And now we're going to go a little more. Okay. And a little more. Jesus, beautiful. Okay, and now we're going to go up north again. Just bring that down a little bit more. Okay, let's try that, shall we?
Sure.
So, it's kind of funny, you know, we know our way around the sky enough to know that, you know, where we are roughly, but even without alignment, I can still, I think, bring out a wonderful, fun time for everybody, I hope. So I hope you're okay with the fact that we don't have an alignment on specifically, you know, where we are. We're fixing that, right, obviously. But I'm beside myself with the fact that the solar flare kind of took us out. Okay, this next one is going to be 24 seconds with that major cloud, probably right about here. I bet you I got it too low, but that's all right. I want to see what's up above it anyway. I believe that's probably the center line of the galaxy. Yeah, it's right there. See that? All right, let's go live stack that and see what we get. Like I said, this is the kind of thing we see with our raw frames, right? And I gotta clear this. That's the old one. But now, with this one, we're actually starting to overlay images on top of each other and stack them all together. So we're getting the benefit of the processing. So we have a beautiful dark nebula here. And I think I'm above it now, Daryl. I think it's down below now and to the left.
Mm-hmm.
Which is okay. I'll be interested to see what it looks like. So on the right behind me here, behind my head, okay, down here you see where it says right there a number of images stacked. It says 2. Okay, so it's stacked 2 images. You watch over there, it tells you how many images it's stacking. As this progress bar makes it all the way up to this, that'll change to a 3 because it's automatically aligning and stacking, aligning and stacking. All right. And
got an interesting color contrast between those 2 brightest stars over on the right hand side.
Here?
The very bright one, the brightest star in the field right there, yes. Then there's an orange one to its upper right.
That one?
There you go. Yep.
Yeah, cool. Okay, we got 3 frames, so now I'm going to see if I can get an auto processing look at this. Holy cow. Look at that. Wow. This is stunning. This is really stunning. Look at the stars, guys. Oh. I could watch this come in all night.
Mm-hmm. I bet you will, too.
I know. It's 1:48 here, and I'm not even remotely getting ready to shut down. I probably have to, though, you know, because I got to be up early. I'm actually filming, I forgot, Thursday, all day I'll be filming for A&E's Season 2 of The Proof Is Out There. Now, they keep adding stories to my list, you know, because I guess the voice of reason amongst the chaff. So I'll be doing analysis, and my son and his production company actually are the ones that are going to do all the filming, so it's kind of cool.
Cool.
Yeah. Yep. Look at these 2. These 2 dark nebulae are just so cool. Sitting out there.
Very crisp, too.
Yeah, I think it'll get even better. I mean, there's only 6 frames stacked, you know, 24 seconds. So it's not bad. I mean, when I look at if we zoom in quite far, I just want to see. Let's go to 100%. So we're going to go to 100% of the frame, so like the full size. Okay. This is what the full size of the frame looks like. So now we can see there's some subtle issues that have to be addressed. And the focus might actually be just a bit soft. So I'll have to run it through the process. I didn't try refocusing tonight. Because, again, it's just a test. But a heck of a test it is, huh? See the noise? You can see the noise here. That rainbowy color. I can eliminate all that. And I will. But it's just a... wow. It is just beautiful.
That's a lot of stars.
Yeah. Wow. That's an awful lot of stars.
In the deeper parts of the dark clouds, you can see some very red stars too.
Yes.
Which, again, whether that was reddening, extinction, whatever you'd call it,
Interstellar reddening. Yep.
Yeah,
it's probably due to
actual red stars.
Now that's got to be an NGC object right there. You know? And sorry about the music. I wanted to have music tonight, guys. I tried to get it running. But I haven't streamed in enough time that I can't remember how to do it. And so I'll get help from Keith at P&K. He'll help me out. I tried.
I haven't sung on a stream for a while. I could be the music.
Oh,
you probably don't want that.
I'm not. Well, you know what? I mean, how much worse can it be than my singing?
I've never heard your singing.
Exactly. So that gives you an idea. Wow. No, that's cool. If you want to sing, if this beautiful image inspires you to sing, go for it. But just understand.
No, I will not subject anybody to that.
Away.
I generally have to have some alcohol in me before I'll sing anyway.
Oh, okay. Well, you know what? Hey, C&D boy, how you doing? If you notice, we got these beautiful dark nebulae we're taking pictures of. This is the Arizona Observatory. We are live and capturing the most beautiful imagery out there. It's the monsoon season out there, like I mentioned everybody, and so the monsoon season, unfortunately, is going to cause the skies to not be as clear. I'm tired, sorry. But this doesn't look like not clear. This looks beautiful. You know?
If the monsoon in Arizona is like the monsoon here, you'll see it clear up after dark every night.
It tends to do that, actually.
And then come back again the next day.
Yep. I remember going out to Phoenix, I should say. I'm not there now. To do a show with I have a robot that goes out and entertains, and the robot was running around out at where was it? Some resort in North Phoenix, and as it was doing that, every morning it would thunder and lightning. And the streets would fill up with water, and then they would drain, and then be gone. And by the afternoon, it was abysmally hot again, you know, the kind of a thing. Really, quite an amazing place. Wow, this is something else. And as far as the speed at which this is all running, it's running a little bit slower than it can, actually a lot slower. And that's because we're waiting for our Starlink hookup. Once we get Starlink, we're going to be moving literally 10 to 15 times faster with all the mouse clicks and everything. It'll be just like live TV. It really will. And I'm just looking so forward to that. You know.
Is this still integrating, stacking, whatever?
Yes, it is. Yep, it is indeed. Let me see if I do this another time. Does it do more? Yeah, look at that. Wow. That's pretty impressive, that dark nebula. You know?
Hmm.
Yeah. I can also adjust colors too over here. And if I was getting a very blue background, I could remove blue and stuff. And very simple stuff, you know? But boy, this is just gorgeous. I'm going to hit pause on this. And I'm going to save it as it is here. Save as a 16-bit stack. I mean, it's already aligned and all set, so I might as well just save it. And there's the directory it's going to. It's going to this sharp capture directory. This directory is going up to the cloud right now as we speak. As soon as the picture's taken, it's shipped right out of the desert up into the cloud. That was really cool. What I'm going to do is I'm going to drop us down, Daryl, because we've got this really interesting arc that I'd like to explore. What do you think? You could have
Go
guessed.
for it.
You could have guessed, though.
Oh, yeah.
You could have guessed I was going to do that, yeah. Okay. So long stack for now, and off we go. And let's bring up our telescope and our control. Again, it's going to be 10 to 15 times faster. It'll be instant. I'll be so spoiled by freaking Starlink. Okay, we're going to take these stars and move them up. This star should go to about the top of the field. And we should leave things kind of where they are. So we're just going to go south a little bit and see what happens. Okay, go south a little bit more. Do it again. And again. Almost. One more. Okay. And now I'm going to head west a little bit. Pull in the rest of that arc on the other side if I can. There we go. Okay, so here we are. We're looking at this scene right here, okay? When you look at this, you can't see the dark nebula in here, but it's there. And as proof, what we're going to do is take a 24 second exposure and capture. It's capturing now. It's taking the photo now. And we'll see if you can actually see any dark nebulae in just a 24-second exposure. I think you're going to see darkness that you can't really explain. And it might be blue because of the filter. But here it comes. Ready? Go. Boom. Oh, look at that. I think we caught the whole thing, Daryl.
Uh-huh.
Look at that with all these little clouds. Holy cow. Wow. Okay, and it's going to take another one. We're not stacking yet. But if I were to do a little bit of processing on these individual frames, this is what you get, okay, because it's blue. It makes it look blue. But you can see them. Now I'll undo that. And now we'll go in and do a live stack. We'll just wait for this next one to come in. You'll see it come back. So this is being replaced by this next image. Go, and we got a satellite coming in. How enjoyable. I told you, the other night I saw over 100 satellites. About 100. You know? Okay. Is this the same? I'm going to clear this and start again. All right, so we're starting the stack over. All right. Yeah, well, tell you what, we're going to wait on this one. Did I say that the other one was the money shot? This is the money shot. This is a beautiful photo for tonight that's going to be coming out. So I don't want to have a satellite going north to south on us. Those north to south birds tend to be the military spy satellites.
Yeah.
All right, let me clear it one more time. All right. So we're kind of near the middle of the Sagittarius star cloud, I think. Maybe not. It's hard to know because this is a location that's really just incredible, you know. Okay, we're gonna let 3 frames stack up here, and then we're going to gonna mess with them. Wow, this is gonna be really pretty. Oh yes. Okay, one more coming in. So what do you guys think? Was it worth doing this in the desert? Just wait till we actually see some of the things that we want to see directly. Okay, the temperature is at -10 centigrade on the cooler in the camera. So we are at -10 Celsius. Okay, let's do some processing on these 3.
14 degrees Fahrenheit, I think.
And, oh my gosh, look at this.
Wow.
Look at down here. Look at the difference in the color and the texture. This is like 3D down here. Holy cow. Hi, Chantal. Welcome to SkyTour LiveStream West. This is... Oh, wow. I'm just blown away. This is just fantastic. Look at that. And it's all being saved. I love it. Let me put me in the middle of black space. I'm just really very pleased with how this is coming out. Holy cripes, this is just beautiful. Oh. And I'm only doing a 24-second exposure. I could do a 5-minute exposure, but no one wants to sit through that. We can actually do better by actually doing shorter exposures and stacking more of them and then changing the gain. The gain's at 350 now. But look at this. Oh. Yeah. Let me try some other processing, see what happens here. Wow. What do you think of that, Daryl?
I think it's wild.
Isn't it crazy? It's just crazy good. Let's see if we can grab anything else. Let me see. Let me drop this level down a little bit. Wow. This is look at how much stuff is in our galaxy. Isn't that crazy? And here's what's interesting, and Daryl pointed this out earlier. If you look inside these clouds, the stars look more orange, don't they, than the stars outside the clouds. And that's because basically the sunset effect. It's the interstellar reddening. You're looking at the starlight that's going through a lot of dust. And just like the air and the particles in our air redden the sunlight when you're looking through more air on the horizon, looking toward the setting sun. In the same way, you're looking through more stuff between you and those stars way in the distance. You're looking at stars that might be 15 to 18,000 light years away, maybe a little more, maybe up to 20, 22,000 light years away. depending on where we're looking. I tend to think this guy right here has got to be a very well-known feature, Daryl. This has to be a well-known feature.
Yeah.
And I don't know what it is offhand, but it's
Me
probably a
neither.
Barnard object.
Yes, I can. I think I can think of two Barnard objects offhand. The horse head is actually a Barnard object, isn't it?
Yes, it is 33.
Yeah, and the big one above Scorpius, they call it the Pipe Nebula. I think
Yes.
it's a Barnard object also.
Yeah. I can't wait to shoot the elephant's trunk from here.
Mm-hmm.
You know, up in Cassiopeia area. Chantel, thank you. I'm so glad you could join us tonight. I know that for some people the timing is off. Well, it works for some and not for others. I see a lot of people here that I've seen elsewhere, but then I see like Tomas Ekberg. Welcome. I'm so glad to have you with us. Make sure you guys subscribe to SkyTour LiveStream, okay? I mean, this is stuff we just do out of the goodness of our hearts. Daryl Mason is with me. He's with SkyTour LiveStream. He's also on the radio show with us, SkyTour Radio. It's an astronomy radio show. It's actually the only astronomy radio show on the KGRA lineup. KGRA radio. It's out of Ogden, Utah, where it's being broadcast from, but it's on streaming services like iHeart and other streaming platforms, dozens of them. And we capture a pretty good audience each month. You know, we reach, from what they say, approximately 2 million people a month. I'm not sure. We're getting real numbers soon. And it's a really cool astronomy show. And Daryl does his really cool, planetarium setup. We have one it's called Stellarium. And Daryl will take you through the night sky and show you some really cool things to see in the night sky. And then I'll talk about things like the realities, for instance, of why these dark clouds exist. What is this? I mean, look at these things. I mean, it's getting better and better as the minutes go by here, guys, because it is live stacking. So we're getting a clearer and more impressive rendering of this image as time goes on. So I'm just so pleased with this. I cannot believe how good it looks. All this stuff would be invisible from here. This is not stuff that's visible from where I am now with SkyTour East. SkyTour East is going to be taking on a different role. It's not going to be looking wide angle at the Milky Way. It's going to be actually looking at more pinpoint things. And I can't wait to get this telescope aligned again so I could show you things like the Dumbbell Nebula, the North America Nebula. We could probably find it, okay? But I got to find an object that I can latch onto and then sync up the scope. For those who haven't heard, the telescope lost its pointing accuracy yesterday when we had that solar flare come through. And I think you heard Daryl earlier said it was the first X-class flare, which is a very, very high energy flare, to hit us since 2017. That's 3 to 4 years ago. So, I mean, every 3 years, if I had to take a trip to Arizona every 3 years to fix something, whatever, I'm out there almost every month, it seems. And I'm in Connecticut, so I'm 2,400 miles from where all this is going down right now. But we're running it remotely. And for those that haven't seen it, here's an image of the telescope in the building out there. The roof is rolled off. It's an infrared camera, so you don't see the rest of the building out here. And then we have a focusing system that we're using, which is all new to us, and that's this guy here. The temperature right now has dropped in the building to 89.7 just now, Fahrenheit, which is actually 32.1 Celsius for my friends overseas. And the telescope focus changes as the temperature changes. That's just a fact of life with telescopes and professional instruments. So we have to account for that, and we will be. I'm noticing here as I look in here, this image is getting more and more detailed. Look at this little snaky item right here now. That wasn't present earlier tonight in the earlier photos before. We have 22 images stacked here right now. Isn't that something? Holy cow! I do want to find other things. I'm crazy. I just want to keep going. You know. Wow. Okay. Well, I'm gonna pause this stack and save this. Now, when I hit save and I say when I say I'm saving this, this is actually, you'll see the green label that tells you, okay, it got saved. Okay, there it is. That's saved to a directory, and it's immediately going up to the cloud. It's actually probably already on its way. So this will be available to everybody tomorrow. Actually, tonight, if I give you the link, you'd actually be able to get to it, which I think would be pretty cool. All right. Okay. Let's drop this down to our 1 second again. I want to kind of see if we can figure out where we are in the sky, Daryl.
Okay. The object in the very bottom left corner sure is dark.
Yeah. That might be partially from the vignetting, but I'm going to try. I know what you're saying. We were on that before.
Yes.
But I'm going to... Remember, this was up in the upper right. We said, ooh, what's that? Well, that's the rest of this.
Yes. Yes.
So what I might want to try and do is go higher into the sky. I think we might be near the large Sagittarius star cloud here, which is at around minus 30 degrees in what we call declination. If you imagine the Earth's equator just spread off the Earth into space, you got plus values up to 90 at the North Pole, then minus values down to minus 90 at the South Pole. And that's called declination. It's measured in degrees. And then we have a 360-degree circle of the Earth's rotation, right? And it's also of the night sky. If you imagine extending the longitude lines, the lines that go up and down on the Earth, out into space, okay? The celestial equator is one special latitude line. Then there's a whole bunch of others, 10, 20, 30, 40, all the way to 90, and then down to minus 90. Well, now the longitude lines, instead of measuring them in degrees like we do on the Earth, we measure them in hours. Why hours? Well, let's say, there's 24 hours in the day. So each of those lines represents 1 hour on the Earth. So 360, degrees is broken up into 24 hours. Okay, and that's how that works. And so we give coordinates as hours, followed by the degrees in the up and down. So the hours left to right and the degrees. And the hours are measured so, for instance, this cloud could very realistically be at a right ascension. It's called right ascension, that special left to right longitudinal lines extended into space. This could be like a right ascension of something on the order of 18 hours, 15 minutes, okay? And it's up and down value, the declination could be something like minus 25 or minus 30. So, it's kind of in that ballpark. That's how that kind of works.
Might mention, too, that each of those hours of right ascension is 15 degrees wide.
Right, which represents an hour of time.
Yeah, it's just like with your analogy of projecting the Earth's coordinate grid out into space. That's like 24 time zones.
Yeah, that's exactly right. Daryl is of course correct. He's got it down from decades and decades of doing this. Us astronomers are a weird bunch. Okay, I'm going to clear this stack back to 1 second. And this is waiting. I'm going to actually get rid of the live stack for now. Okay, and we're going to just go down a little bit. Or no, I think I wanted to go up, didn't I? I think
Yeah,
I
I
threatened.
think you said north.
I think I threatened to go north. Yeah. So let's do it. Let's go now. Which way would be good? It's going to be a little more toward the east, but a little more north. Okay. We're going to go north. Here we go. You'll watch the telescope. No, you won't. Let me just get that back. Okay. So now we'll go north. You'll see the telescope moving up a little bit. And, of course, the stars going in as a result. And now we'll head a little bit east again. I'm trying to sort of stick within the Milky Way if I can. Let's find out if we've got anything here. Let's just do a quick exposure here. I'm thinking we're going to do, let's do 25 seconds here. See what happens. I do actually feel like, one of those early astronomers who's going through the sky. I mean, those of you that know me know that's I went to school for astronomy, so I'm an astronomer. And it's really just an amazing field to be in. I mean, every time you look in the night sky, you see something cool, Hey, Baked Roosters, how you doing?
Well, I was thinking earlier it was
Wow.
sort of like Galileo all over again.
Yeah. Look what we found.
It's like seeing it for the first time.
What have we found here? Look at this. Holy cow. This is really amazing. Ah. Jeez, this is something else.
You got another deep sky object there.
I do, don't I?
Yeah.
That's another
sort of
globular cluster, I think.
Lower left quadrant.
Yes. Yeah. Okay. Don't worry about this right side. I have to figure out what's going on there. Pay no attention. We'll figure that out. But this is just astonishing. Okay, all right. I'm gonna do a live stack on this. I mean, I see dark nebula right here.
Yes.
You see that too?
Yes.
All right. Well, let's live stack that at 25 seconds. And there's actually clusters in here too. Wow, that was something. All right, we're going to... I got to clear this. Okay, now we're going to start over. This will be... What's going to come in now is only going to be an exposure that was picked up at around 18 seconds, so it's going to be a little short. Ho. Sorry, I kind of lost it there. That's beautiful. Wow. Look at the stars. It's like, ah. Isabella's right. Globular clusters are amazing objects. Okay, we got 2 frames stacked now. Wow, there's a difference right there with 2 frames stacked. Jeez. Unbelievable. See, guys, this is why I was telling you I can't wait for the dark sky. I can't wait for the Arizona sky. Why? That. Okay. This is... It's beyond stunning. Beyond stunning. It runs together almost like it's continuous. The stars. But they're not. Okay, 3 frames have been stacked. Let's see if we can do some processing here. Okay. little bit of processing. Try auto color balancing. Yeah, I don't like that. Put too much blue in there. I didn't like that either. Okay. Okay.
I see several, looks like star chains in the field,
Like
to a
here.
particular down in the lower left-hand corner.
Yeah.
Both
Like
look
this.
like curved lines. You think those are just artifacts, chance alignments, or are they real?
Where are you looking? Down here?
Lower left-hand, yeah, right where your pointer is, and there's another one to the upper left of that.
Then this.
No, to the left,
Oh, right there?
to the left,
That is to the left.
farther to the left,
Huh?
farther to the left. Right over on the very left-hand edge and up a little bit, right there.
Okay, that arc.
Yeah.
I think most of those are chance alignments, yeah. I do.
Okay.
Yeah. Because
I know we've seen some like that in the past.
yes, we have.
I want to say maybe somewhere when we looked at the veil one time that they looked almost like they were following the contours of the nebula.
Like a shock front. Because a
Yes.
shock front could initiate stellar formation along the way, but we also have to keep in mind that when the veil occurred, all right, I think we're talking about 16,000 years ago. The veil may have occurred, right?
I don't remember offhand.
Yeah, it's something like that. So what that means for us is that the veil probably didn't have time to generate a shock front that would generate stars within 16,000 years.
I understand.
So it's a matter of timing. So that leaves us in a quandary as to why the stars do align like that, and are they related to a potential, to a potential, shock front. And if not from the veil, could it have been from another more ancient supernova? And the answer is maybe it could have been.
Yeah. I still, figuring the time needed for star formation, you're probably talking more like millions of years, not thousands of years.
Absolutely, yeah,
Yeah.
yeah. But those are all good questions, though. They're all good things to discuss and all good things to ponder.
Well, I was wondering earlier, looking at some of the dark clouds and seeing the dim red stars down inside them, uh, that if we could see in the infrared, we'd be seeing tons of stars probably being born inside those dust clouds.
Yes, as a matter of fact, and like when we look for young hot stars, stars like T Tauri type stars. That's T, and then Tauri, Taury for Taurus,
Hmm.
the star that gave it that name. Young hot stars that have basically just are in the process of winking on, basically going into full blown nuclear fusion in their cores. Yeah.
I suppose the Webb is going to show us inside those clouds. The Webb telescope.
It will be. It'll be able to do that. You're right, because the infrared. And on the Earth, using an infrared telescope on the ground doesn't make a lot of sense. And the reason is because, unfortunately, infrared radiation is stopped by our atmosphere for a good portion of it anyway.
Uh-huh.
So there's really no advantage to using an infrared telescope on the ground unless you're at very high altitude, like Mauna Kea, which is over 13,000 feet in the air, and so it's above a great deal of the atmosphere. So the infrared system can work there.
Yeah.
Yeah, it's pretty cool.
Not to brag or anything, but that reminded me. My sister sent a picture last week, I think it was, where they took some friends or company guests up on whatever observatory it is on Maui.
Yeah, it'd be Mauna Kea.
No, on Maui.
Oh, on Maui, that's Haleakala?
Yeah, Haleakala.
Yeah, yeah.
They took some photographs of it. Looked
Yeah,
really cool.
it's Haleakala is a beautiful site as well. You know.
Yeah.
Wow, look at this, guys. This is like, look, it's 2:25 in the morning, and I'm like, raring to go. Holy cow! All right, we've stacked 17 frames here, and again, we're at 350 gain. The gain, as I mentioned to you before, is over here. You can see right there. It says gain right there, and it's at 350, which you can see to the right. And the exposure is 25 seconds right there. So we're actually exposing for 25 seconds. And what's behind me here are all the parameters for the stack, the stacking that's going on, as you can see right down there. All right. And what's behind me here is the universe. It's just beautiful. So I'll put myself here. I just think that's something else. Wow. Hey there, Fantasy Ecstasy. What's going on? That's nice to see you here. Check out these beautiful images, and these are all gonna, like I said, they're all gonna go up. I'm gonna pause this stack. It's at 20 as of now. I'm gonna pause it, and I'm gonna save it. Oh, I can't believe this. We're saving this as a 16-bit stack. Okay. And it's been saved as a FITS file. I can read those in Photoshop. I have a plugin to read those for those who know Photoshop. You can't read an FITS file natively.
Favor?
Sure.
Before you move on,
Yeah.
could you zoom in on that little cluster, whatever, deep sky thing there?
Yeah, I think that's another globular. I'll do it right now.
Yeah.
Okay. Oh, sorry. I got rid of the stack, so now it's doing a 25-second standard shot here. But that's okay. Let me go to 66% or 50%. And I believe that's a globular cluster over there.
Yeah.
Oh,
Another satellite too.
Okay, popped in. This is all live, dynamic, guys. So you're actually seeing things as they're coming in, which is kind of cool. And we have additional. The stars. These stars look a little elongated. I think that those are actually the guiding could be just a hair better on the auto guider. Again, that's a tweak I have to do. All right. Let's see now. Jeez, this is something else. It's beautiful. Okay.
Which way next?
Anybody's guess.
Your cup runneth over.
I was actually trying to find Bod's window, but I think I gotta wait until we align to find Bod's window. I think we're poking around and being in part of the large Sagittarius star cloud, but I don't know for sure.
I'd wondered a few minutes ago. It looked like there was quite a difference on the left side of the screen versus the right, like maybe you're at the edge of a star cloud or something.
Yeah. Not in this shot, though.
Not in this one, no.
Yeah. See, now if I reduce the exposure to just like a few, like a second or two, that satellite might not be visible that's trailing right now. It's actually pretty faint.
It's interesting that you'd see the satellite this late at night.
Well, it's actually at a pretty high altitude, so it's still illuminated.
Yeah.
At that altitude. If you notice, it takes 25 seconds to go just a fraction, several arc minutes across the sky. That tells us that it's actually pretty high up. And I have a program. I don't want to start it up now and take people's time up for that, but we could measure this and get the exact altitude and speed that it's moving. But see, UFOs.
Might it be a geosynchronous satellite?
No, the geosynchronous satellites would actually stay in the same spot relatively. And they would actually, because the telescope's following the stars, so they would actually leave a trail. It's possible, except that it's 25 seconds. That's not a whole long time. The geosynchronous satellites make a smaller trail, and they're about 17th magnitude. So I'm guessing no, but you could never. You could win that argument if we went and just consulted some data. It could be. I'm on the fence, but I think that I think it's moving a little too fast across the sky.
Oh, just thinking.
No, that's a very good thought. Watch it move out of that star. Leave that star behind here in a second. It's about the next image. Boop. Leaves a star behind. So you see, we're watching the dynamic universe right in front of us with our satellites moving across the sky. Okay, where to next? That's the question. Should we actually try to go up more?
Sure.
Okay. Yeah, this is cool. We might actually happen to find something we want. Let me go up. But first I should have done this first. I apologize. 1 second is what I'm setting. I'm not saying 1 second. Wait, I'm saying going to 1 second here, and now this is all going to go dark. Just a minute. Doop. Okay, now we brought the telescope up a little higher, and let's go a little more eastward. Let me first bring the telescope up. The image of it, anyway. So let's go a little more eastward. Maybe more. I'm dropping down just a little. Okay. I'm not sure where we are, but from just having fun tooling around the universe tonight, look at all the really cool stuff we found. I've been just astonished by this. I'm going to do 22 seconds.
Yeah.
Pretty cool, huh?
It is.
Yeah. And that was
like having
What's that?
It's like having a fresh new view of everything.
I know, isn't it? And it's like, this is your first time seeing SkyTour West as well, Daryl.
Yeah.
It's not my first because I've been working on it and trying to get it to work, and stuff. And but the astonishing things I've seen have actually been pretty amazing. Wow. Darn satellite won't go away. You try scrubbing them out. You try soaking them out. I think we're on the verge of a star cloud here. How about that? Yeah. Let's live stack this. And let's clear this previous stack. Again, the images have already been shipped up to the cloud. Okay, and now we'll see. Okay, that's interesting. I see a satellite, of course, but we see some dark nebula here and here. A star asterism over here. Well, look at that line of stars, Daryl. Talk about a line, huh?
Yeah.
They're like little dots. Okay, 2 frames stacked so far. You don't try to do any processing until at least 3 have come in. And then you can try some processing. Okay, we have 3. Let's give this a shot now. Okay. We have some dark nebula here, fainter, wispy stuff here, darker nebula there.
Very red star at the bottom right.
Yeah, right there. Yeah, right. You're right. Very cool. And a big old satellite. Of course, it's a continuous trail because the exposure's continuing, basically.
Right.
It reads out the data, but the exposure's already continued. There's no time between integrations. Oh, Leslie, thank you so much. That's so very kind to say. Leslie says, I can watch these amazing views forever. Looking at the universe, and I know people that actually put this on their big screen TVs, and they just sit back and watch, which is so cool. I'm working on getting a larger system. I'm getting a big curved monitor that'll effectively be like 2 to 3 monitors. And that's going to be something that's going to help me to do this a little better. Wow, look at that. Daryl's tired. You said you were going to bail after about an hour because you might be tired.
Yeah, well, I'm about an hour past my bedtime.
Yes, you are.
I'm enjoying this.
Yeah, me too. Okay, I'm going to save this one as well. And I'm going to make sure. Yeah, okay, good. It automatically saves that. That's good. Okay, now we'll pause this again and clear. And again, the number of stars is absolutely astonishing. Now we're going to go back to our 1 second finder mode, basically. Yeah.
As Arthur C. Clarke once said, for every soul that ever lived, there burns a star.
That's a very cool thing. That's very cool. Yeah. All right. Let's do this. Where are we here? Thermal controls -10. Okay, camera has reached -10 degrees. All right, that's fair. 1,000 milliseconds. And okay, and this will be 1.1 seconds, basically. All right, let's take a hike a little higher in the sky. And I never do it without looking at the telescope. I got to see what it's doing at all times. All right, so we're going to head up north a little more. Okay, if you look in the dome, you can actually see, not the dome, the building, you can actually see the telescope is moving a little bit at a time. Ooh, that's kind of interesting. I think we're onto something here. Let's go just a tad west. I don't know if we are. Those could all just be clouds of stars. But let's find out. Okay. Oh, there we go. That's something right there. Is that a globular cluster?
Whoops. Sorry. Kind of looks like it.
Yeah. All right. Here's what we're going to do. We're going to do 25 seconds here. And then we're going to live stack it. I hope you guys like the live stack feature because it's actually just such a difference in how we've been able to view our imagery.
Oh, it is. It's cool. You can see the image build up.
You watch it build up, yeah. You know, the first image is kind of rough. The second image is a little cleaner. Oh, look at that. All those stars. Wow. The globular cluster here that we were looking at is literally overexposed in this 25-second shot. Wow, this is impressive. Impressive. Most impressive. But you are not a Jedi yet. Oh, wait. It wouldn't be said like that, would it? But you are not a Jedi yet.
There you go.
Yes. All right. We're definitely in the Milky Way area. There's no doubt about it. Definitely in the Milky Way. Look at all these thousands of stars. Yeah. Okay, I'll pause this stack and save it. This is only a stack of 3. But you know what? I'm going to resume. I'll tell you why. I'm actually going to try and do some processing to see what else is hidden in here. Okay, looks like mostly star cloud here. So doing what I did is probably the right thing. Okay, or we'll pause this.
I'm seeing all sorts of small, finer scaled dark lines in that image.
I see them too, like through here and all that.
Yes.
And some of that might be an artifact of your vision looking for something regular amidst the irregular. And some of that might actually be real dark lines. Dark dust. We need to explore that. Like right here, I see 3, maybe more, maybe hundreds of them coming down like this. And I'm not sure. That might very well be there.
To the right, upper right of that globular thing, just a little bit to the right of the globular, a little farther.
Okay, like up here.
There's two of them almost parallel.
Yeah.
Farther to the right.
Like right here?
Right there.
Yeah.
Farther to the right.
Like there?
Right there, those two.
Yeah. Yeah, and I wonder if that is our minds causing us to do this or not. I'm not sure. But either way, I'm going to save it and pursue it. It's only 4 stacked images, but then again, it didn't seem like there was a whole lot happening in there. I could probably, I'm sure I could be very wrong. Okay. All right, let's get rid of the stack here. Let's clear. And go back to our regular view. I will fix all this words across the top so that it actually looks okay. Again, you're watching a live stream that is evolving. We have new systems, and I'm using the old systems for what we did. We left behind the DSLR cameras, and we're now using specific cameras for astronomy. Big change, much higher expense when it comes to that, but not by much, actually. The camera that I'm using is actually cheaper than the Sony camera we used originally, oddly. But the Sony camera I used originally did 100 different types of things. This one does one thing. It's a one-shot color camera that takes beautiful pictures of the sky. Okay, now, where was I going to go from here? We're all set there. I want to actually try to see if I can go up a little higher. Maybe I can actually locate something important. Okay. I think I can do without the telescope view for now. All right, I'm going to just do a singular 25-second shot here. 25 seconds seems to be my go-to shot, you know, for whatever reason, because it tends to show everything you need, especially with this camera and especially with the speed of this optical system. Okay. Let's go see. Wow. I mean, now here's the thing. Just think, everything you're looking at right down there. We could be seeing thousands of civilizations, or maybe none. It's any or all. It's really hard to know, you know. And Arthur Clarke, as you said there, oh yeah, for every soul that ever lived, there burns a star. Yes, but for every soul that ever lived, there burns a star for sure. I can say that. But there's more stars in the universe than humans that could ever. Well, there's more stars in the universe, actually just in our galaxy, than there are humans that could ever live on Earth, now and in the future. From all the way from the first humans to the last humans on Earth, when the sun goes, they still won't get to the numbers of stars in the galaxy alone. So it's really an interesting thought problem when you think about it.
Yeah. Well, when he said that, that was back in the 60s, and I guess the the numbers were a little lower back then.
Yeah.
It's interesting. Well, you talk about seeing lines of stars again. There's a figure 8 down at bottom center.
Right here?
Farther down.
Here?
Right there.
Oh, I see it.
See the figure 8?
Very obviously. Yeah, see it? One circle, and then there's another ring up above it.
Uh-huh.
Yeah. Interesting. The human mind looks for those patterns, and they're there. They're definitely there. So we're good at picking those patterns out, is what I'm getting at. Hey there, huh? Yeah, you should have seen some of our shots that we've taken so far, huh? We've got some unbelievable dark nebulae this is a simple shot actually, and basically is just, you know, this is just a little fake, you know, false color. But this is the actual shot as it looks. And then what I want to do is, you know, because it's taking more shots as we go here, but we're going to go and just take another, we bring it down to 1 second so we can actually move around in the sky quickly and get the live view. All right, so we're going to go up a little more. And again, just so people understand who may not be aware, we're going kind of haphazardly through the sky tonight only because the telescope, unfortunately, was knocked out of alignment by the solar flare that occurred, the X-class flare. That was yesterday, right, Daryl? I think it was.
It was a couple of days ago, I believe.
Okay. Because my telescope's been out of alignment for, I think, 2 days, actually. So I think you're right. And I was really surprised because it was perfectly aligned. And then I came in one night, you know, a couple nights ago to test it, and bam, it started going to all the wrong places. Like, whoa, what happened? I looked up and I discovered that there was a problem with the sun. It decided to have to burp off this gigantic X-class flare, which was just no fun.
When you say alignment, I mean, obviously the telescope is tracking, looks pretty darn well.
Yeah,
it's polar aligned. It's just it's lost its place.
It's lost its place. It doesn't know where it's pointing in the sky. It's perfectly aligned with the sky in terms of alignment. We're doing multi-second shots here, and you don't even see any real issues.
Yeah.
Okay, so let's see. This will be the first 22 seconds. Let's see what we have here. Okay, I think we've come out of the Milky Way a little bit here.
Yeah.
So let's. I am getting tired though. I'm gonna end up having to actually call it a night. I mean, how long have we been going already?
We started going a little after midnight your time.
2 hours 43 minutes.
Yeah.
Not a bad bit. But then again, you know, and people know this. How can I stop when it's this good?
Huh.
Right? How can
just one more?
I'm Mark. Just one more, D'Antonio. That's my name. Just one more. But see, because we can't find specific objects, see, that's the problem. Okay, so now, on our, just past the southern, straight up, okay. So what we can do is go back to telescope view and go back to our this view here. I wonder. Let's try going westward for a minute. I'm going to go westward because I'm going to try to see if there's if I'm in the right place that I think I am. I may not be. Let's go back here for a sec.
So you think you've moved east of the Milky Way?
Perhaps, because the Milky Way is on the southern meridian right now, roughly. So that's kind of where we are. So, okay, we're going to take another picture here. This is only 12 seconds, but I want to try and get an idea. Okay. As you can see, even though our telescope lost its alignment, it's just so much to explore out there. I'm going to head back east again. Here, you watch the telescope in the lower right, you'll see it's going to move to the right a little bit. Okay. I think I'm back in the Milky Way. Back in the Milky Way again. I don't know. And this looks like some interesting location here. I'm going to head south a little bit. Drop us down. Oh, I'm doing 12-second exposures. I'm sorry. I'm going to make that just 2-second exposures. Okay. And then drop us down. I'm just going on a search right now, guys, just to look for something. Because, like, the telescope effectively is blind right now. It doesn't have any connection to the sky other than it can see stuff, right? But I'm trying to find... oh, is that a satellite? Oh, look at that. We have a satellite moving across the view, guys. Right here. See it? If I increase the exposure, you'll see it better. So 4 seconds, and you'll see the trail. Here we go. Ooh, it's really faint. Really faint. It's actually it's actually fainter now because it's actually faded out. Whatever sunlight it was catching, it went out. So that was cool. Okay, well, but I bet you it's possible that if we did a quick 25-second shot, we might catch it. Not sure. Let's find out. We might still be able to catch it, in other words. Oops, sorry. I'm blocking a whole bunch of things. Okay, 3/4 of the way done with this exposure. Alright, and let's see what we got now. Look at that. Wow. It's like, no matter how much of an exposure you take, there's always more stars to capture. It's really beautiful. Yes, and so you guys, thank you for coming out tonight to our first public SkyTour LiveStream West viewing. Again, problem with the telescope was it's not aligned anymore thanks to the solar flare. But it doesn't mean we can't steer it around and go check things out. And boy, we did tonight, man. We had some really, really beautiful objects we were looking at. Lots of dark nebula and stuff like that, which is really spectacular. I'm going to zip way over to the west. Oh, darn it. 25 seconds again. I keep forgetting. Can make that 1 second. Okay. All right. Very nice. Okay, now we'll go over. Also, for those that didn't hear it, we're activating a system in the observatory where you see the star field like right here on the screen. The telescope will have the ability to identify those exact stars and thus be ultra high precision aligned at all times. And that's it's a process called plate solving, and it's something that's going to allow the telescope to always know where it is in the sky. And that's going to take care of problems with the solar flares. Should it happen, I can just plate solve again and just go to a field and say, where am I? And the telescope will say, well, I know where you are. And it will let us know where we are, and it'll be able to align us. So that's kind of what we're going to do. Let's go way west again here. See the telescope moving.
I assume that's what some of the fancy telescopes are doing automatically nowadays, where, it's been like a whole evolution since they put GPS units on them. Now I've read of some that all you have to do is sit there and turn the telescope on. It will automatically figure out where and when it is. I guess starting with GPS to know when and where it is on Earth, and then is it doing plate solving, I guess, to figure out where it is in the sky.
That's right. And that's where I'm heading with this.
Yeah.
So that we no longer have to worry about solar flares and glitches like that. And for those that don't remember, I said earlier tonight, the power going into the observatory goes into a industrial surge protector, and the cables are buried underground, go 160 feet to the solar panel power. This observatory is entirely green, by the way. There's no dependency on fossil fuels for this. This is all powered by the energy from the sun. The energy comes from 2 large solar panels that follow the sun during the day, courtesy of the scientist who allowed us to put the observatory on his property. And so we're also currently piggybacking on his internet, which is satellite internet, which is slow as molasses. So as a nice thing that we're going to do as soon as the Starlink comes in, we're going to install Starlink out there both for him and for us and take care of that for him, because I think that he's more than generous. He and his wife, they've been more than generous in giving us what we need. So I'm very happy about that, and I'm very excited that he's basically opened up his land to us. He's just an amazing human being. Okay, I'm going to bring us down a little bit lower now. It's still in 22 seconds, but I'm trying to get... I'm gonna change.
Mark, will you excuse me for the evening, please?
Of course.
I'm about to fall asleep sitting here. It's been a great night. I really enjoyed this, and I can hardly wait to see what happens once you get it realigned.
Yeah,
Uh,
it'll be great. You know, if I
yeah.
can do the plate solve software remotely, I'm going to. I do have it ready to go. I just have to ship it up to the observatory
Uh-huh.
that way. So if I can ship it electronically, I will, and I'll work on it and install it, get it running. Okay, Daryl. Well, thank you for
Super.
joining
Okay.
us.
Well, thanks again. It's been great.
It's
Good
been a
luck,
wonderful
and
night.
everybody have a good night. Okay.
Been a wonderful night. Thank you, Daryl.
You betcha. Take care. Thanks
See you
for
later.
having me on.
Okay, of course. Good night.
Bye bye.
Wow. So yeah, there we go. We have we have done some amazing things. Okay, let me bring us back now. Okay, and I'm gonna drop us down a little bit more. You can see the telescope moving in the building and coming down substantially. I have an idea. We'll stay with that. Right, and then I'll come over here and drop us down to 1 second again. What do you guys think of the new interface? Let me know what you think. Okay, and all right. All right, let's see now. We're going to do this. All right. This will be a 15-second exposure just to see what we've got here. Oh, look at that. Another globular cluster. So that's pretty interesting. That globular cluster right there. They can have 20,000, 30,000, 50, 60,000 stars, all in like an exploding snowball of stars. They're really beautiful, and they're called halo objects. They're actually outside our galaxy. They're orbiting our galaxy, and they come down through. They plunge through the disk of the galaxy and keep going, shedding stars, picking up stars, and then they come back up through. In some cases, some of them are farther out, some of them are closer. So they do that kind of that orbit. You know, I feel the need to actually do something here. I'm going to do a 25 second 25 second shot here and a live stack at the same time. I just don't know why, but I'm going to, because I see a strange darkening at the top, and I'm wondering if it's actually just my imagination. What is the mount's rotational calibration? Well, the mount basically is designed to follow the rotation of the Earth, and that's working fine. But the calibration that's really needed is what we call the alignment. And the alignment is where it knows where it's pointing in the sky. And then we can steer it to very specific items in the sky in various places. The solar flare blew that out of its memory, even though I'm all surge protected. So clearly there was a lot of current coming down through the atmosphere to the ground, where it ran through bedrock and made its way to Arizona and blew this out. But it didn't destroy it. It just scrambled its brains, and that's it. Okay, and so that's all. So I'm gonna actually 25 seconds. I'm gonna resume this, and we're gonna stack this now. Okay, this is 25 seconds. Wow. Guys, this night has been just so phenomenal. I can't believe the beautiful objects we caught tonight. Beautiful dark nebulae. Okay, what's going on here? Let's clear this and do it again. Wow. Yeah, it's been a while, James. But this is why all this stuff you see, took time and effort to develop and to get up on the, get running. And that's just you haven't even seen the behind the scenes. I kind of showed a little bit about the building of the building out there. It was really quite a feat of engineering, especially since I couldn't be there. I had to do it all remotely through telepresence. And if you ever tried building a building in telepresence, it's impossible. But it worked out okay. It worked out okay. Okay, I'm gonna pause this stack here, and I'll just clear it. I'm not gonna keep it. Okay. Wow. Well, I will make these other images available to you, but I'm starting to lose track of my faculties as well. It's 3:13 a.m. and I've got to get some sleep. So I'm going to. Okay, see that fuzz? You know what that is? That's a cloud. So it's actually not a bad time to do this. All right. Let me just do this. I'm gonna close it down with you guys so you can actually watch it and see what happens. Okay. And we actually have clouds, which is kind of interesting. So the monsoon season in Arizona, this happens. So I'm going to disconnect the camera. Okay, this is the camera that's connected, the ZWO-ASI 294 MC Pro. And then I can close that. And then, once that actually closes, then I can, I gotta leave that connected because I gotta move the scope. Then I can disconnect the focusing system, which is here. Sorry. All right, so disconnect the focuser. And shut it down. I don't have to do everything manually. I just choose to. Okay, and now what I'm going to do is I'm going to drop this down a little more. You can see that it's coming down. It's actually going to face right into the webcam, actually. You'll see it face right into the webcam here shortly. And it's going to get pretty bright. Well, maybe not that bright. Maybe so. Okay. Alrighty. Yeah, it's pretty bright. Okay, so then what I'm going to do is I'm going to move it eastward a bit. You'll see the reflection going with it. Okay, and that's the reflection of the infrared light. There we go. Okay, I bring it down a little bit more. Unfortunately, because it's not, I mean, this process would have been over already. If it was aligned, I would just hit this button here that says park. But I can't do that, unfortunately, because parking it now, it's going to send it to a different place, which could involve taking this camera and slamming it into the fork. So we have to be really careful now. All right. However, I can now disconnect the scope. So I'll disconnect it. Okay, so it's disconnected. Oh, look at that. I got a bug in there. Disconnect the focuser. Okay. Close the program. Yes, I want to close. And then we have only two things left to do. And that is I have to turn off the pure power, and because the telescope is going to be shut off now. So I'm going to hit this, and you'll see on the left, you'll see, okay, turn off pure power. The pure is now shut off. The telescope is now shut down. And now what I can do is close the roof, and you'll see the roof close. Here we go. Good night, telescope. That's 2,400 miles away from here. All happening. And that's it. Our building is closed for the night. The telescope is put to bed for the evening. And we're ready to go and check out the next phase. This directory here, Sharp Captures, when I go in there, you're going to see that it's a directory like we expect to see a directory, but it's got some different dates in it, all right, including 7/7 to 2021, which is now. And all of the captures that we created and took will be in here. Okay, and these captures will also be synchronized up on the cloud. So I have raw frames, and I will have captures as well. These are raw frames, but then there's actually stacks that are also saved up there. So you'll see those as well. Okay. Okay, so I'll wait until tomorrow to actually start looking at these things, and then we'll go from there. right, so I think we're good. Now that was 7/6. We started at midnight. So I wonder, was this last night? This must have been last night when I was doing it. Yeah. Okay. All right. Well, guys, I want to thank you. I wish I had some great music for tonight, but I got to fix that part of it. And I will. But telescopes put to bed, roof is on, all closed up for the evening. So we are set to go bye-bye. And I will talk to you guys on the next stream. And now that I know what's wrong with the telescope, we'll endeavor to get out there and fix it. I might actually head out there in a week or two for just like 3 or 4 days just to realign everything and get it ready to go. So this should be fun. Okay. So you guys, hey Martian, how are you? The files are already being sent up. They're already being synchronized with the cloud right now as we speak. By the time I wake up tomorrow, I should say it's already tomorrow, but by the time I wake up in a few hours, they will already be there and we can check it out. So you guys have a good night. I will definitely be talking to you, in the near future as we embark on more SkyTour LiveStream West. You guys have a good night. We'll see you later.